Hi class, this is our second video of section 4.7 covering financial models. In the previous video, we saw it's actually a better investment to invest at a 7.9% interest rate compounded daily than an 8% interest rate compounded semi-annually. So what this leads us to think is that maybe the number of times that the investment is compounded is the most important thing. So I want them to add money to my account constantly. Of course, the shorter the time period, the smaller the amount of money that's being added, but still. That's what theorem 2 addresses, the continuous compounding formula. So the amount A after T years due to principal P invested at an annual interest rate R compounded n times a year as n approaches infinity is given by A equals PE to the RT. You'll remember that E is that number that represents what happens as n goes to infinity of 1 plus 1 over n to the n power. So this kind of makes sense with our previous formula. Okay, so let's practice using this one. So if you have $100 to invest at 10% compounded continuously, how long until you have $175? As before, we need to figure out what is A, what is P, and what is A, what is P, what is R, and what is T. Okay, you'll see that we don't have N because you're given continuous compounding, so that means N is approaching infinity, and we have to use the other formula. Okay, so we're investing $100, so P equals 100, and we want to get $175, so A is 175. We're given that the interest rate is 10%, and the question is how long? So we're trying to solve for T. Okay, once we've identified these, we put them in the correct formula, which is this one, because again, it says it's compounded continuously. So that's how I know to use the continuous compounding formula. So then I have 175 equals 100 times E to the 0.1 T, and I need to solve for T. Now this looks like one of the problems from section 4.6, and this is why we had to learn how to solve exponential equations. All right, I'll prefer to divide both sides by 100. So then I have 175 divided by 100 equals E to the 0.1 T. And now T is stuck up in the exponent, so I need to use a log to get rid of it. So the log of 175 over 100 equals 0.1 T. And to get T by itself, I just divide both sides by 0.1. So T equals the log of 175 over 100 over 0.1. And when we get the approximate answer, it comes to be 5.6 years. Great. Let's see a couple more examples. Number 7 asks, how long does it take for an investment to triple in value if it is compounded continuously at a 6% interest rate? So first of all, when we see that it's going to triple in value, we know now that means A equals 3P. And when we see compounded continuously, we know we need to use the continuous compounding formula. We are given that the interest rate is 6%, and we are asked how long. So we need to find T. Plugging these values in, we will have 3P equals P e to the, 0.06 t. So because p is multiplied to both sides, we can cancel p. So we have 3 equals e to the 0.06 t. To get t out from the exponent, we need to take the log of both sides. So the log of 3 equals 0.06 t. And finally, to solve for t, we just divide both sides by 0.06. So t equals the log of 3 divided by 0.06. And when we take it on our calculator, we see that's approximately 18.31 years. Pretty long time, but we're asking to triple an investment, so there's that. Okay, so question 8 is one more of those comparison questions. Jim places $1,000 in a bank account that pays 5.6% compounded continuously. After 1 year, will he have enough money to buy a $1,060 computer? So we can answer that. There's also a second question. If another bank will pay 5.9% compounded monthly, is this a better deal? All right, we'll answer the first question first. And in the first question, we're given continuous compounding. So we use the continuous compounding formula. And we know the values of P, R, and T. So we can find out what A is. So A equals P times E to the R times T, which is $1,058 approximately. So to answer the first question, will he have enough money to buy a $1,060 computer? No, he won't have enough. Okay, so then we can look at the other scenario. So we have a higher rate, but now we are compounded monthly, not continuously. So we need to use the first formula. So we have A equals P times 1 plus R over N. So in this case, we're told it's monthly. So N is 12 times a year to the power of 12 times 1. It's still a 1-year investment. When we put this one on our calculator, we get about $1,060.62, which is a greater amount of money, and now he can buy his computer. So we can answer the second question by saying, yes, this is a better deal.